Okay, so let's get started. We're going to be taking a look in this training module at working with and programming our variable valve timing. Now we're going to be using our in-house demo vehicle, which is a Honda EP3 Civic. It has a Honda K24 high compression engine installed into our chassis. We have our vehicle here fitted to a mainline chassis dyno, and we're going to be going through this calibration process, showing you how to dial in the variable cam timing and working with the chassis dyno so we can see the changes as we're making them. We will actually want to build a cam composite blend table using our cam targets, and we want to be able to get the best torque band possible out of our engine. So we're going to be demonstrating that, and specifically I'm only going to be working with low cam. So there's a low cam, high cam with a Honda engine, VTEC. So we're only going to be doing low cam for the tutorial, just in the interest of time, because this tutorial could get quite lengthy if we're doing both low and high cam. But what we're talking about here and how we're calibrating is going to apply to any variable valve timing engine. So it doesn't matter if it's a Honda engine or let's say it's a 2JZ VVTi engine, it doesn't matter. What we learn here can be applicable to other variable valve timing engines. All right, let's jump in here and take a look at a few details, and then we'll fire up our engine. We're going to do some PID testing to make sure that our variable valve timing is going to be accurate in terms of the feedback control and the closed loop system here. And then we'll start to baseline on 0 degree variable cam angle in our target table. Then we'll work our way up and build a cam composite blend table, looking at how the variable cam timing is going to be affecting the torque production of the engine, and then putting together something that's going to give us, again, the broadest torque band possible for the engine that we're working with. Now, there are some things we can keep in mind and to pay attention to as we're dialing things in. If you don't have a chassis dyno, it's the best way to do variable valve timing tuning. But if you don't have one available, there are some marker points that we can pay attention to in terms of our fueling delivery as we're going in and making the variable cam changes. It's going to tell you very clearly if the change that you're making in your variable cam target at a certain RPM band is going to be a positive gain, meaning you're gaining torque, or it's going to be a negative gain, meaning you're going to be losing torque and losing essentially the engine's efficiency. So we'll have to pay attention to these details as we're going through this training module. Let's jump in here and find our variable valve timing layout page, and then we'll discuss what we need to be aware of before heading into doing the tutorial. So I'm just going to go over the setup and control here. Let's go into our layout drop down, and let's go all the way down here into our VVT window. So if we're scrolling down through here, it's going to be about midway down through our layout options. So let's select VVT. Now in our window here, we were in our last tutorial going through a lot of the variables and programming details. I'm just going to run through what we have in the setup and into the inlet bank, and we're going to talk about our variable target table here. Then we'll fire it up and go through the PID setup, just making sure that's right. So first things first, our cam control mode is set to Honda K20 VTC. When we select this option, this will be associated to the engine that we're working with here. We see there's a lot of different common VVT equipped engines. You'll probably find pretty much any engine you'll run into for tuning in our drop down list here. Now, because this is a Honda K24 engine, the Honda K20 VTC pattern is still I want to select. What this is doing is telling the link that it's expecting to see the specific cam pattern for this engine on our cam input. So that's going to be tracking our VVT position. It's also going to allow the PID gains to be populated that link has determined for this engine. So the proportional, integral, derivative gain, as well as the feed forward duty cycle for the system to control from. Now we can go in and change any of that, and I'll just go demonstrate seeing if we can tweak and adjust that a little bit. Usually out of the box, when you select any of your engine options here, the PID gains in the feed forward are pretty solid, and they do require minimal, if none, changes to be made. So just kind of keep that in mind, but I'll go through the extra step of just checking everything so we can ensure that everything's going to be accurate. So that's going to be what we select here for this engine. Cam angle test, we're going to go through that real quick when we fire up the engine. That's going to determine our inlet bank 1 tooth offsets. This is going to be tracking the various tooth values in the pattern that we're working with. So for a Honda K20 engine, for the VVT cam position sensor, it has 4 teeth, and this is tracking where the 4 teeth are going to be. This allows the link to know the position of the engine within its cycle and within the variable valve timing movement. That's how we can actually track things accurately. So this does have to be populated for the engine you're working with, and that's what we use our cam angle test function to do. I'll demonstrate that again here a little bit. Startup lockout, 5-10 seconds is generally acceptable. RPM lockout, I'll say 1,000 RPM and below, we're not going to allow any variable valve timing to start to do anything. So we want to control at the neutral or 0 cam target position. So that's 1,000, 1,200 RPM is fine there. ECT lockout, we could say don't allow the variable cam timing to start to work until we get above this ECT range. It probably wouldn't be a bad idea to allow the engine to warm up a little bit so the oil viscosity can thin out a little bit and the control can probably be a little bit more accurate. So I'll say at least 100 degrees coolant temperature before I want the variable valve timing to actually function. That's pretty normal. The Honda factory ECU waits till I think it's about 70, 80, 90 degrees Fahrenheit before it actually, in the coolant temperature, before it actually allows the control. PID setup, we want to go and change this from default right now to custom. Now when we do this, we can see here the options for advanced users only. Incorrect settings can cause permanent engine damage. And yes, we want to go ahead through with this. This is going to be under our in-leg bank 1. It's going to go and expose the base or feed forward duty cycle that we want the control from. It exposes then our integral, proportional, and derivative gains, which we may potentially want to go and adjust. It also allows us to see a filter option. So going in there with the custom option gives us some more flexibility in the programming. Now, the values that we find in here, so all these values, these are values when we select this cam control mode that Link has determined that will run a stock engine. So they don't usually require much of any adjustment, but again, we're going to go through that just the same to make sure everything's good here. Now, there is an active inlet table, and this is set to 2 tables. This specific engine is a Honda K-Series engine, so there's a low and a high cam. Low cam will have its own variable cam timing table, which is going to be our inlet target table 1 here. High cam, or when VTEC is activated, that'll have a secondary inlet target table. So we have 2 tables here associated to low cam and high cam, or VTEC off and VTEC on. That's pretty normal to map things out for a Honda K-Series engine. That's exactly how the factory ECU does it. So I like to stick to that same type of routine. If you're dealing with something like a 2JZ VVTi engine, you're only going to have 1 variable cam target.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.